I presented back in March of 2016 on the phase one. So let's just kind of run through that between the phase one and starting phase two. So then spring and summer of 2017, we did some geoprobe work. It took some wireline cores, and then we finalized and submitted the maps. I'm going to try to click on this link right here. These the maps and the individual quadrangles are available. So here's the New York State Museum page. So if we scroll way down, so these are all our publications available for the public. And let's see, let's get down to, all right, so here's a Hancock quadrangle. If you open it up, you'll get our full maps and chart series available, museum website for you guys to look at the quadrangles individual. And here's the quads that we mapped. Phase one was Hancock. DOT calls it Cadocia for whatever reason, but everything else calls it Hancock. Fish's Eddy all the way down to Narrowsburg. Phase two, which we'll get to after the quick rundown of the phase one update, was Eldridge, Shahola, Pond Eddy, and Port Jervis North. The geoprobe, which is a drill mounted on like a skid steer size tractor, essentially drives a pipe, hollow pipe in the ground, and we can take some cores from it. We did 10 Mile River Scout Camp property off of Crawford Road. Derrick Road was DEC property. We got a radiocarbon date. We also got an OSL date from where this red star is. An OSL comes out of sand. We take a sample of sand and we send it off to a lab in Colorado. Unfortunately, we're still 2017. It's now 2021, and we're still waiting for results. So all of our, I'll say OSL a bunch of times in this presentation, and that will be all of it. Results are pending, unfortunately. But it's essentially a way of dating quartz grains instead of carbon, if there's no carbon present in the samples. So this was our radiocarbon sample, and that's our OSL sample. So Derrick Road was DEC property. We did manage a radiocarbon date out of it from, it was mostly glacial till, but it was mostly because we figured the hillside would cave down a little bit, because hillsides are always falling. It might not look like it, but they're always falling. So this was some of the geoprobe work we did. So that's where the AMS date. So when I say AMS, I mean carbon dating. Kelms Bridge, we didn't find anything. So the Kelms Bridge site, we'd have an OSL date from, or an OSL sample taken from some sand and gravel deposits up the railroad tracks. We're still waiting for the results from that. And then the geoprobe ended up being mostly just kind of wetland sediments from Holocene that didn't yield anything. Wireline coring, 1723, Fred Peckham's. So 1723, took the sample, probably we're about 150 yards off the river, up on the flats a little bit. We ended up about 160 feet to rock, around there. 160 feet total, about 150 feet to bedrock. And again, here's the OSL sample mentioning, and this is significant because we took the OSL sample from the base of the core. So we went through lake sediment, we went through alluvium on the top, and we went through glacial till and lake sediment. And then below the glacial till, we actually went back into river sediment. So kind of sand and rounded gravel and things like that. And this sand and rounded gravel is old. I can't say it's completely pre-glacial, but it's at least, it means it's older than any of the glacial sediments that were in the river itself. So when we get an OSL sample back, that gives us a minimum date. It'll give us a minimum age date of the Upper Delaware River Valley. So that means, when I say minimum age date, I mean so that's the bottom of the river valley before the till came in. So it can only be that young, but it can be a lot older. I was mentioning about the core on top. This is likely glacial lake sediment. And we're looking at essentially seasonal laminations, the kind of reddish, thicker portions and clays. And those are usually deposited when the water's moving very slowly to not at all. So in the winter time, when everything's frozen, there's no running water feeding into the system. It quiets down enough that the finer materials like the silts and the clays can settle in and form these beds. The kind of blacker, grayer looking beds in the picture there, those are kind of medium sand. Those kind of give us let us know that there's enough water velocity to bring the coarser material in the system. So essentially it's kind of telling us that there's potential lake sediment in the system. So this was a cross section based on 1750, 1751, and then down here at 1723 around the bend. This was the cross section we produced. We have lake sediment above the till, then it goes down into the bedrock, and then you can see, as I mentioned at Fred's Well, that there's some actual old river sediment underneath all of that glacial sediment. So again, from the geologic time standpoint, it's going to be a real interesting data point if it comes back as reliable data. If some of you guys probably are aware of the old project to dam in Fish Steady Quad to dam the East Branch in the Peasetti area, but they had a guy named Floor did some great geotechnical work to assess all these sites. And there's lake sediment in this area of the East Branch, as well as down the rest of the main branch, the upper Delaware. Just the overview of the maps that we submitted. I kind of combined some together to get a better picture. So this is Hancock and Fish Steady. As you can see, it's predominantly, the red is bedrock, the blue is glacial till, and the orange is the sand and gravel deposits that were left likely by glacial ice that was sitting in these valleys and depositing. And the glaciers are just a dirty mess, and that as they melt, they shed off sand and gravel in these areas. So we can tell that there was at least glacial sediment. The red star that just appeared on the red bedrock, that actually represents a little tan mark. That is another OSL sample I took in 2016 in phase 1, and that was several tens of feet above the river level. So that tells us that water was depositing a delta up at this level at some point. So the water in these valleys were likely dammed up as glacial lakes all the way up to at least this point. And then we're going to kind of keep exploring that as we go south into phase 2. Lake Como, we included in the mapping, even though no roads went into it, but thanks to Fred Peckham, I was able to wander around over here a little bit, and that was mostly an old sand and gravel pit. And again, till and bedrock are kind of the main sediments in the area. Bedrock not being a sediment, but glacial or geologic material. So here's Kelms Bridge, where we did the geoprobe and took an OSL sample. And then this might be Basket Creek. I'm not positive, but could be Calhoun too. There's sand and gravel deposits all up along this. And as we keep going, you're going to see, again, OSL sample.
Yes, that's Calhoun Creek up that river valley. That stream valley is Calhoun Creek.
Okay. All right. So yeah, coming down here. So that was Calhoun Quadrangle over here. So phase 2, obligatory picture of Hawk's Nest. So my point for this one is, though, the Mon Gap on the other side is just a massive deposit of sand and gravel. I mean, hundreds of feet thick. So let's move on to here. Basically, project methods is to gather the prior work, review the LiDAR, doing the field mapping. I started in the fall of 2018. We had actually hired somebody to do the mapping, and they quit in like 3 days and didn't actually start the project. So I had to pick it up. So then after the field mapping, I drafted the maps and wrote up the report. So prior work, we have some NYSGS files, had the old New York State Surficial Map that we obviously are updating as we do these quads. This bulletin here is also available. So this is the lower Hudson of the Surficial Geologic Map. This was made back in the 80s. So the red square is the area that I've mapped, that were mapped in phase 2. So the pink just suggests that it's till. So obviously there's a lot more bedrock in there than that. So just a quick zoom in of it. Yellow is sandy outwash, which is pretty accurate, but the detail on this isn't very great because they're trying to map the entire state in a very short amount of time. So let's keep going. Bedrock. It starts down. So if we start down here in Port Jervis area, there's Silurian age rock along the Shawangunk Ridge on the flank of the Shawangunk Ridge. That's what it's called in New York. It goes across to turns into Onondaga, some Onondaga bedrock, which is middle Devonian in age, and then it gets younger as we go into the Catskills. up the river valley. So here's our, all right, which is fine. It was just the same Bedrock map zoomed in. So this was the overall map as we turned it in, all the quads kind of lined up. So again, here's these valley trends of sand and gravel kind of running north-south, and these extend out of the mapped area way up into the Catskills. So this is the red dots on this are our field observations. So about 200 field observations with 163 samples collected for grain size analysis. The one down here is the only one that we took in the actual Upper Delaware River scenic and recreational river area. The other two are pertinent to the project and the information of the natural history of the region. So the distribution of the materials, just mainly in the river valley, was quite obviously alluvium, sand and gravel, and silt sediments. Glacial till is the most abundant, followed by bedrock and exposed on the surface. Sand and gravel deposited up the tributary valleys, and they're usually bedded, but sometimes massive. I don't know if I'm calling it the right thing, but the Never Sink Valley. So that's full of mostly bedded sand with some gravel. In the maps again, sand and gravel deposits up these valleys. We're going to zoom in on this area right up here. This actually has glacial interest in the glacial history of it. This is Swamp Pond Road, and these are Kame and Eskers. In Eskers, I have the definitions here for us and some diagrams. The Sinuous Ridges, these are Eskers, and these are deposited underneath ice. So this is water flowing under the ice in tunnels and carrying sediments and depositing them along the valley bottoms. And when the ice melts out, because it was not a lake, wasn't cutting, it was depositing in these ridges are what's left in the landscape. And Kame deposits are similar. They're deposited on the ice. So when the sediment is left behind after the ice melts out, we're left with these hills and knobs on the landscape. So this is an example of these eskers. There's a quarry on Swamp Pond Road that was cut out, and you can see the bedding, the gravel and the bedding in the sand around here. So that it's an example of these eskers that I found. This was probably the best example I found in the area. So Shohola, predominantly till and bedrock with some sand and gravel, and moving over towards the Mountain Gap where we have just large amounts of bedded sand, probably melting out of the Catskills. Shohola. So this is another New York City DE boring project, and I put these in here and included them with the report mostly because there's red. These red silty clays are representative of lake sediments in what's the present day river valley. So here's a delta up in Port Jervis, or some kind of fan along these sand and gravel deposits. To note, we're going to talk further too. Also, this kind of a lighter brown. These are glacial moraines, and we didn't have any. I didn't find any in phase one. In phase two, I was lucky enough to find this guy. So we're going to continue to talk about that too. This is a Rio Road Quarry. This is another example of Kame deposits in the Delaware River Valley area. So this is going back. This is where the quarry was located that I was able to get access to. These are faults and fractures we see through here and folding. These are actually representative of, so as these Kames were being deposited, as the ice melted, they actually stretched out the sediments, and we get these fractures. And these faults actually start developing in this unconsolidated material. This is Port Jervis, Liebolt Road Quarry. I was able to gain access to, and they had just great exposures of bedded sand. You can see this is finer grain sand of some kind of coarser grain, medium sand. Now let's get into these moraines and ice margins. So one thing we have here is missing is these are glacial moraines. So they're actually showing the extents of glaciers moving through the area. This is the glacial map. So this is essentially where they're making the assumption that ice came down into Pennsylvania and stopped before it started melting back at the end of the last glacial cycle. And if you can see through the Catskills and the Delaware River Valley area, there's no margins really that are clearly mapped except for this Ogden's Culver moraine here in northern New Jersey. And so the dates and the history of the ice advancing through the area and melting back out is actually really unknown through here. So this is what we're hoping to find out with these OSL dates. So here's the moraines that I pointed out. If you can see kind of these scraping striation marks on here, this is ice that had glacial ice that has actually come out of the Hudson Valley and across essentially Orange County and pushed up into the Catskills. And it likely advanced to this point here, as far as we know, to this point here. And it also built up moraines on its way back down. So you'd get these cycles of advance, and then they'd recede and then sit here long enough to deposit sand and gravel and till and glacial till in mounds. This long moraine here actually will have a larger. Here's me on the moraine. So this is the Heartwood Quad, or Heartwood Hunting Club, up in the northern part of the Port Jervis North Quad, and it has the moraine is made of essentially boulders that have been have minimal sand and silts and clays in them. They're just piles of boulders that are strewn up there. And if you can follow the red line, this goes up towards Monticello and down into Pennsylvania. And without modern elevation information like LiDAR, it's never been really identified before. So this is a larger image of that, and you can see it continuing up. I'm going to see if I can zoom in on this. There we go. So you see this material here. I don't know if I can go in any further. So it's kind of this kind of, I want to say crenulations to describe it, but this kind of material here that's kind of sitting on top of the bedrock and the till in the area. So, and we can see here, this is the old map, the old Surficial Geologic Map. The purple would be the moraines, and they're not present in the area where it should be. So these are in the woods, really well hidden, and the LiDAR has allowed us to actually identify them. So here's Pennsylvania. This is available on the Pennsylvania website. And you can actually follow, here's the New York moraine, and you can follow it down into Pennsylvania along here. And we can also do the same thing. So here's more of it in New Jersey. We're just assuming that this is the same moraine for now. So this is the Ogden's Culver moraine this is the one article New York State Museum bulletin I was talking about, or publication. So this is the Ogden's Culver moraine, and they just kind of have a question mark out here and over here about what happens to it. And they're just assuming it just goes down towards the LGM. But there's actually no moraine material that kind of suggests that that's happening. So it's actually very likely that this moraine coming down the ice as it pushed out of the Hudson Valley, pushed up into the Catskills and stopped and stayed along this point here. It may likely be, it's not the LGM. It's likely aged with the Ogden's Culver moraine, so it'll be younger than this terminal moraine, but it's a pretty significant data point because it suggests that the Catskills were ice-free earlier than people initially thought. So here's a delta. This is the Wilson Road Quarry. I ran into some town guys. They were doing some road maintenance, and I asked to get in there. So I took some OSL samples. So this is an old delta. So this was being deposited in what was likely a lake that was filled in this whole area, and probably, and I'm going to show a picture later on momentarily of the significance of this delta in the elevation it is above the actual present day Delaware River Valley. So these are we call these foresets. So these are actually dipping, and they're the sand that was being deposited probably out of the Mongap River Valley or somewhere nearby. And these are being deposited. So these beds go flat, which is another indication. So we call these foresets and top sets. And when you hit this foreset point, it's a definite indicator that this is a delta and that this is a lake level. And we can take this point here, this contact here, which is about 896 feet above sea level. And we can make the assumption that there was a lake at this height, at this elevation, filling in the Delaware River Valley in this area. So this is it. We're proposing would be called, at least in this area down here, Glacial Lake Sparrowbush. The big caveat is that we don't know. So as I showed you through this presentation of all those sand and gravel deposits that were filling these valleys, where if there was ice blocking off parts of the Delaware River Valley and not allowing this lake to be continuous, but if this lake was continuous, it went all the way up to Point Mountain in Hancock. And I've looked at the drainage basins for kind of that northeast Pennsylvania, and it doesn't reach, this lake in this elevation would not reach Lake Wallapopec. So this lake would have been contained to this area that's kind of shown on this map, with just a little bit kind of coming to the south where it's not, where I didn't have access to this LiDAR. So again, here's stage one. This is the quarry, that Wilson Road Quarry that I showed you, and the moraine. So the ice would be essentially parked right up against this red block and across the valley where I showed you guys this moraine. So if we can picture that this valley through here is actually just covered in ice. So it's just a big glacial sheet of ice. And then as it melts back, there had been a second stage where ice was still filling the valley down here in Port Jervis, but blocking enough that there was still water, except at this point here, this little nick point here, which we're going to zoom in on in the next slide. So again, so here's the ice, the glacial margin is right here. The fan, that delta, I mean, is now buried, is submerged underwater. This whole area is actually ice. So water is filling up the Delaware River Valley, and this is going to pull back. And then this spillway here, right about here where I'm pointing with the cursor, is the same, is lower than the elevation of where I showed you at that 896 feet. And that's Cummins Creek in Pennsylvania. And that drain from Milford to Mill Rift, this channel was the actual drainage point for the Delaware River, or at least Glacial Lake Sparrowbush at the time. And then it melted, so after draining through this, and the ice melted back again down into the valley, it would have started draining. Ice would have been starting to drain out kind of along the rock faces. And we know this happened in the Catskill, further north in the valley. And so it's where we're going to kind of briefly talk about the scoured rock here from younger glacial lakes from the north of the Catskills. They'll start draining as the ice pulls back and just blasting off the rock as it drains off against the ice sheet that would be still the glacier that would still be filling the valley as it kind of started to melt back down towards the Hudson Valley and north out of the Neversink Valley. And I wanted to acknowledge the national parks for the funding. Dwayne Braun, who was a professor down in Pennsylvania, he helped me out immensely in phase one. And the summer interns that we had, and the landowners like Fred Peckham, and the other guys that allowed us to do the work on the property.